Hello everyone, in this video we will compute or derive the formula for the volume of a sphere. So first of all, what is a sphere? So as a sphere you can imagine a ball, right? A ball with equal distance to from the center to each of its point, right? So at the middle of the ball you have this circle of radius r, and then this ball curves to form the top half and then curves to form the bottom half, right? So this is over here r, this is also over here r, and from the center to any point to the surface of the sphere the radius is r. So how do we compute the volume of a sphere? So we'll approach it by just taking the semicircle or the hemisphere, right? The top half of the sphere, getting that volume and multiplying by 2, right? So the volume of the sphere is going to be 2 times the volume of the hemisphere. But then how do we get the volume of the hemisphere? So if you think about the hemisphere, it's basically made of multiple circles, right? So at the let's pick the top hemisphere. At the very bottom you have this big circle of radius r. Then maybe some way into the sphere you have a smaller circle which with a bit smaller radius, not exactly r because this is curving. And then at the very top you get to just a point, right? So you can imagine putting a point, a small circle, a small circle, a bigger circle, all the way until this circle of radius r together, and this is a circular shape, right? And together, that added up all together forms a sphere. So if you look at this, at the very bottom you have a circle of radius r, right? Radius r, and then this curved surface here dictates the change in radius as the height goes up, right? So here the radius is r, here the radius is 0, right? So let's say radius of the circle here is 0, radius of the circle here is r, r here being the radius of the sphere, right? And so if we break this sphere up into very small cylinders, right? So this is dh, right? And then add up the volume of each cylinder across this sphere, then we can get the volume of the hemisphere, right? So at this height here, so we have here a height of 0. Here the radius of our circle is equal to r, right? Because it's the biggest circle, where again r is the radius of the sphere. Our area here is equal to pi rc squared. This is always going to be the case, so whatever rc is, that's the area, and then the volume is going to be pi rc squared dh, right? Where h is the very small height that we've allocated to each of these circles, right? So at the top, where rc is 0, our h, let's say, is equal to r, right? Because this is r, this whole thing is r because it's a sphere. So at height equals r, our rc is 0, right? And then the area and the volume follow, right? They're the same formula. So now the question is at any arbitrary height h, right? So let's say I assign some arbitrary height here h. How do I get this rate r sub c for this h, right? So if I draw this again over here for simplicity, we have a circular surface here because it's a sphere. This is the center of the sphere because this is again, imagine this is the top half of the sphere, this is the center, right? And then we know that this is r, we know that this height over here is r, and we want to find the r sub c at this given height h, right? So at any given height h, if this is h, what is r sub c? So if we draw a line, we know that this is 90 degrees, right? Because this is the height, this is the radius. So this is 90 degrees over here. So if we draw the hypotenuse of this triangle, we know that this is r because this is a circular surface, right? So this is from the center to the surface is r, center to surface is r, and this whole thing is a circle. So from the center to any point in this arc, the radius is r. So then by the Pythagorean theorem, we can compute r sub c is equal to r squared, which is the hypotenuse, minus h squared, which is the side here. And this is r sub c squared, right? So the Pythagorean theorem says that h squared plus r sub c squared is equal to r squared. And so just doing the reverse, if you want to compute r sub c squared, it's hypotenuse squared minus the height squared, right? So at any given arbitrary height h, r sub c squared is equal to r squared minus h squared. So then, we can plug this into our area and correspondingly the volume. But now that we know how to get the area and the volume of at any given height h, all we have to do is sum up from height equals 0 to height equals r the volumes of all the circles that we encounter along this arc, right? So the volume of this circle, and then this circle, and then this circle, so all of the horizontal circles, right, until we get to the smallest circles on top. We want to sum up the volumes of each of those small circles or small cylinders. So to do that, we use the integral, right? So it's the integral from 0 to h, right? Because this is 0, this is h in terms of height, right? So it's the integral from 0 to h of the volume, right? So the volume is pi rc squared dh. And since this is just the volume of the hemisphere, because this is, remember, we're just taking half the sphere. So to get the volume of the whole sphere, we just multiply this by 2, right? And so now let's substitute our values of rc, and since this is a constant, let's take it out. So this will be 2 pi, right? We take the pi out, integral from 0 to h of rc squared. So rc squared is just r squared minus h squared, right? And we take here dh. R is a constant, right? Because r is the radius of the sphere. So we simply take the integral here. So integral of r squared, since that's a constant, is going to be r squared h minus the integral of h cube is going to be h cube over 3, and we need to evaluate this from 0 to h. From 0 to r, right? Because this should be 0 to r, because the highest height will be r. So it's integral from 0 to r. So we need to substitute r into h. So it is going to be 2 pi times, we evaluate this first using r, so this is going to be r cube, because when h is r, this is r squared times r, minus r cube over 3. And then when it's 0, obviously, all of these are just 0, so it doesn't matter, since h will be 0. And so with that, r cube minus r cube over 3 is 2r cube over 3 times 2 pi. And so distributing this, we have the volume of the sphere is equal to 4 thirds pi r cube. And that is how we derive the volume of a sphere. So I hope you enjoyed this video. I'll see you in the next one.